All right. Good afternoon. Thank you all so much for coming. I'm really glad to see you all here. Thank you for coming this afternoon as we're getting into the mid-afternoon doldrums, perhaps, but very, very happy to be here with you all. My name is Julia Silge. I'm a data scientist at Stack Overflow. You can find me there on Twitter, or you can find me there. At my personal website. And what I am here to talk to you all about today is text mining. But I'm going to be talking about text mining from a particular perspective, from approaching text mining using a particular programming idiom, and that is by using tidy data principles. And what I want to do here today with you all this afternoon is I want to make the point that using tidy data principles when we approach text mining makes text mining easier and it makes it more effective. And what I mean by making text mining easier and more effective is that more accessible to more of the kinds of people who are starting to do text mining. Easier in the sense of easier to integrate into workflows that are used by many data analysts and data scientists, and more effective in the sense of easier to reason about and easier to make choices for. So this work is based on an R package. So this R package is here on GitHub. This R package is available on CRAN, the central R package repository. So I'm an author and developer on this package along with my collaborator, David Robinson. And this package is called Tidy Text. And the point of this package is to provide functions and supporting data sets so that data analysts and data scientists can approach text mining within the universe of tools built for handling tidy data in the R ecosystem. So this includes packages like dplyr for data handling, ggplot2 for data visualization. So what tidy text offers is a way to do the text mining tasks that we want to do within this universe of tools that are widely used by many data scientists and data analysts. So what do I mean by tidy text? If I'm standing up here and saying, I think we should use tidy data principles when we approach many of our initial exploratory data analysis for text, what am I actually saying? What do I mean by tidy text? So let's start and walk through a very small example using a poem, part of a poem by Emily Dickinson. So first, let's take that little bit of text here, 4 lines from an Emily Dickinson poem, and let's assign it to an object called text. So in R, we would call this a character vector. You might think of it as a raw string if you're a Python person. And if we look at what is in text, it just reads out as this. It's just strings. It's just strings. We can load the dplyr package and then put this into a data frame. Now it is in a data frame format with types here, and we can add another column that's gonna tell us which line which line of the poem are each of these lines for. So we now are to a data frame, but this is not yet what we would call a tidy data format. Tidy data, in the sense that we're talking about it today, the most important thing to remember about it is that it has 1 observation per row. Often what this means in practice is instead of having very wide data frames where you take more observations and you add more rows, if you take more observations and you add more columns, I took more data, time to add more columns. That's not tidy data. When we take more observations, we add more rows at the bottom. So what we want to do here is we want to load the tidy text package and use the function unnest tokens that will take our untidy data, and that it is in the column text, and it's going to convert it into a tidy text data frame here where the words we'll have a column called word. So now instead of reading the lines of the poem across, we're going to read the lines of the poem down. Notice a few things here about what's happening after we've done this transformation. First of all, there's a lot more rows than we had before. Second of all, the other column that we had is still there. So that means we still know which line of the poem each one of these words came from. So we still have the metadata about each one of these words. We stripped out punctuation and converted words to lowercase, and these are the defaults in the unnest tokens function, which just usually sets us up for the kinds of analyses we want to do later on. So that was a wee tiny little bit of text that we tidied and we were able to do something with. Now let's take a bigger chunk of text that we might be able to do something a little more interesting with. Let's take the 6 published, completed novels of Jane Austen, and let's tidy that text. So the novels of Jane Austen are available in R, in the Jane Austen R package. So we load the Jane Austen R package and dplyr and string R here. We can set up a data frame. So we're going to set up a few other columns here. We're going to set up a line number column that's going to tell us what line of the book we are on. So that's just like lines as if we were reading the book. And then we're going to use a regex pattern to detect which chapter of each book we are on. We're grouping by book here, so notice that's something that's going to restart over when we get to each new book. So this looks like this. This data frame looks like this. So the text column contains the actual text content of each of the books. And then we also know for each line of text, we know which book it's from, which line in that book it's from, and which chapter in that book it's from. So we've set up our data frame, and now we can use unnest tokens to transform it to a tidy data frame. So after we use unnest tokens, we have a much longer, skinnier data frame where we have one observation per row. The observation in this case that we're interested in is words. So we have one word per row. So we did it. We tidied the data. It's very exciting, I know. I know you're all glad that you came to this talk and you were very exciting. But why have we done this? What is the point of embracing tidy data principles when we work with text? What is the benefit? Why is this an approach that analysts and data scientists may be interested in embracing? The benefit here is that there are many text mining tasks and natural language processing things that you want to do that become natural extensions of tidy universe actions that you want to take. So for example, removing stop words is often something that we need to do during text mining or exploratory data analysis when you're exploring a text data set. And if your text is in a tidy data format, you can remove stop words using an anti-join operation. So you can use dplyr's anti-join to remove stop words if your data is in a tidy data format. After that, we can just use dplyr's count, and we can ask and answer the question, what are the most common words in Jane Austen's novels? And we get an answer like this. So the most common words in Jane Austen's novels are words like miss, time, dear, lady, sir, and also some proper names like Fanny, Emma, and Elizabeth. So we're able to get to this insight very quickly with just a few handful of lines of codes because we've embraced tidy data principles and stored our data in a tidy data structure. This is an example of a kind of question that we can ask about term frequencies, about counting words, and a lot of quite interesting analyses can be done just with that, just with like looking at word frequencies and making smart uses about how and what we're counting and in what ways. This is another example of a kind of analysis that I did recently. So this uses a data set of pop song lyrics and asks the question, what states are mentioned more and less often in song lyrics? So if we look at this map, we can see that states like California are mentioned most often in song lyrics. As you probably can imagine, New York, there is, those are all mentions of New York City, as you would expect. But perhaps you look at this map and you think, you know what, California is a very populous state, so there's just a lot of people there to start with. So maybe what we're actually interested in is what states are mentioned often relative to how many people live there. So we can just divide by the populations of these states and then find out that states like Hawaii and Montana are mentioned most often relative to their population. So these are states that have a big impact on pop culture relative to how many people live there. So Hawaii, Montana, and then the states in the Deep South. So these are states that have a lot of impact. So this is an example of a text mining analysis that you can do based on just word frequencies on word countings. We can use it, accomplish it using tidy data principles in that way. So first here off, we've talked about what does a tidy text format mean for text, and we've talked about word frequencies. The next thing we're going to talk about is sentiment analysis. So one way to implement sentiment analysis is what what you would call bag of words, or sentiment analysis based on using a lexicon. So lexicons are lists of words that have some scoring associated with them. So the sentiment lexicons don't contain all English words because some words are quite neutral. They don't have a strong opinion or emotion content, but some words do, and so these words are scored in different ways. So some sentiment lexicons score words according to how positive or negative they are on a numeric range. So say from -5 to 5, like the AFIN lexicon. Some lexicons score their words in a binary fashion, like yes, no, like this one is a negative word, this one is a positive word. This one is a sadness word. This one is a joy word. So if you embrace a tidy format for the text data that you are dealing with, then you can implement sentiment analysis using an inner join. So we can take our tidy version of the Jane Austen data, use an inner join with a sentiment lexicon, and then what we have at the end is all the words that are in both the text that we're studying and the sentiment lexicon. After we've done the inner join, we can again count, but with multiple arguments. We can count by book and by an index where we're counting up by sections of text in the book, and also by sentiment. And with just a couple more lines of code from tidyr, where we're spreading things out, we can get to a visualization like this, where we can see how sentiment changes through the course of these narrative arcs. So we can see what sections that have more positive words, sections that have more negative words. And these sections of extended sentiment correspond to events that we as human readers understand as happy or sad. So for example, in the center of Pride and Prejudice there, where we have that really extended section of negative sentiment, that's where Mr. Darcy proposes for the first time so badly, and Elizabeth is so horrified, and there's so much conflict. And that section about 3/4 of the way through Pride and Prejudice, where there's a lot of another section of extended negative sentiment. That is where Lydia elopes with Mr. Wickham, and it's a terrible scandal. So we can use sentiment analysis implemented using tidy principles and an inner join here to get to insight about what this text is about and what it's telling us. So we've talked so far about what a tidy format for text is. We've talked about how we can use word frequencies to do an analysis and sentiment analysis. And we can also see which words contribute to each sentiment. So we can count and get at which words are contributing here. So notice some things here. We can see which words are contributing most in the negative direction and in the positive direction. And we can make a plot like this. So let's look at those positive words. What are the words that are contributing the most in the positive direction in Jane Austen's novels? These are words like well, good, great, like, better, enough. Those all make sense, right? Like these are words that Jane Austen is using to communicate happy things. Let's look at the negative sentiment over there. We have words like poor, doubt, object, sorry, impossible. Those are all negative words. But what about that top word up there at the top? The word miss, right? When Jane Austen uses the word miss, she's not using that in a negative way. She's using it as a title for a young unmarried woman. So this is an example of when our sentiment lexicon has misidentified a word as negative that is not negative in the text that I'm using. So this is a problem when we're using sentiment lexicons, that they don't always match up with the way that our text is using these words. The great thing about using tidy data principles for doing text analysis is that it's not hard to discover these kinds of problems. To be honest, all we had to do was use count with one more argument instead of the kinds of arguments we were doing before. It was very easy for this to pop out and for us to see, oh my goodness, the word that's contributing the most in the negative direction is miss. Not only is it not hard to find the problem, it's not hard to correct the problem. All I would have to do at this point is remove miss from the sentiment lexicon. I can say, it's not appropriate to use miss in the sentiment lexicon as a negative word for the text that I'm dealing with. Let me remove it from my sentiment lexicon and then move forward with my analysis from that point forward. So embracing tidy data principle makes it easy to find problems and easy to fix problems as well. So the next thing I want to talk about is how to programmatically get at what is a document about. And so we're going to talk about something called TF-IDF. So term frequency is something that measures how often is a word used in a document. So it's pretty simple. You just take all the words in a document and you divide how often is one word used by the total. Inverse document frequency is a weight. So it's a weight that applies to a document within a group of documents, sometimes called a corpus or a collection. So the inverse document frequency is a weight. So you take the natural log of the number of documents over the number of documents that contain the term that you're interested in. So let's say you have a collection of documents and they all contain some word. So then the ratio inside of that is going to be 1, and the natural log of 1 is 0, and so that's going to get weighted down. That weight is going to be 0. Let's say you have another word that you're looking at, and it is only in one or very few of your documents. Then that ratio is going to be a number bigger than 1, and the natural log is going to be a number bigger than 0. So that's how that IDF term works. It's a weight. So if you take TF and you multiply it by IDF, you end up with TF-IDF, and it's a statistic. It's supposed to measure words. It is supposed to measure words in a document, in a collection of documents. So that's what you apply it to. And the idea is to find words that are distinctive of one document compared to other documents in that group. So it's going to find words that are common, but not too common. So you're going to get around the problem of very common words like the, and, to, and of, but not in the sort of blunt force way of stop words. You don't have to just decide ahead of time which ones to take out. You're going to use a more sophisticated approach here to find which words are important to your document and your collection of documents. So calculating TF-IDF lends itself extremely well to using tidy data principles. So first, let's just look at term frequency. So we actually can just use plain old vanilla dplyr to calculate term frequency. So we can just count up how many words are in each book, how many times is each word used in each book, and we end up with a data frame like this. So in each of Jane Austen's novels, how many words are there? How many times is each word used? And then what's the total? So Mansfield Park is the longest of Jane Austen's novels, so it's up here at the top. So now we have this data frame with the words and how many times they are each used. These distributions look like this. So these are super common distributions in natural language. These are power laws. This is called Zipf's laws, another name for it. These are like, we see this all the time. We see this in the distribution of cities by population. We see this in the distribution of salaries. We see that this is one of those things we see all the time in many, many places. So if we take this distribution and we now decide to calculate TF-IDF, so there's a function in tidytext for binding TF-IDF onto a data frame like this. And here we see TF, which is just actually those two numbers divided by each other and divided by total, then IDF, and then TF-IDF. So notice here that IDF is 0, and that's because, as we talked about before, all of Jane Austen's novels contain the words the, to, and of. So then you multiply TF times IDF, and you still have 0 there. But instead, let's take this data frame and let's arrange it so that we can see the highest TF-IDF words. So now we're looking at the words here that have the highest TF-IDF. If you're familiar with Jane Austen's work, you know who these people are. But even if you're not familiar at all with Jane Austen's work, you can tell that these are proper nouns. These are the names of people and places. So what have we just found? We just found that Jane Austen used consistent language from one book to the other, and the things that are most distinctive about one book comparing to another book are the proper nouns, the names of the people and the places. So TF-IDF is a very powerful technique that can be applied to many different kinds of text. Not just several hundred-year-old narrative text, but many, many different kinds of text. And, one area that I've used it for in the past year or so has been as part of the NASA Datanauts program. So I've worked on a project to understand NASA data sets. So they have over 32,000 data sets that they are in charge of shepherding. And these data sets have a lot of metadata on them, like title, tags, which are human assigned, descriptions, which vary from very short to medium short, right? And then like which sub part of NASA is it from, and lots of other kinds of metadata. So I calculated TF-IDF for the description fields of these NASA data sets, and then compared this to other things about the data sets that we know. So for example, what if we say what are the highest TF-IDF words for these description fields compared to the keywords that we have on these data sets? We see a definite signal here of how we are able to see these differences. So for example, if we look at data sets that are labeled with the keyword budget, there we see high TF-IDF words are words like OMB for the Office of Management and Budget, fiscal and financial. If we look at data sets that are tagged with the keyword human health, we see high TF-IDF words like well-being, vulnerability, and children. So these are this demonstrates that TF-IDF is something that can be applied to technical documents as well as extremely long narrative documents. It's an extremely powerful and flexible technique. So far, I talked about only things at the single word level. And I said we want to have one word per row. But actually what I said was we want to have one observation per row. And sometimes we're interested in things beyond just the single word. Often when we're modeling text or just doing exploratory data with analysis with text, we're interested in groups of words, which are called n-grams. So if you have a group of 2 words, you would call that a bigram. If you have 3, you would call that a trigram. And there's lots of things you can do when you start to extend your analysis beyond the single word level. So if you have groups of, for example, all the bigrams in a text, you can start to make a network and do network analysis of text based on how the pairs of words are connected to each other. If you do bigram analysis and then look for all the all the bigrams that start with a negation word, like not, or no, or never. Then you can start to look at how has negation affected my sentiment analysis, because that bag of words sentiment analysis does not take into effect, for example, the sentence, I am not happy. You know, bag of words sentiment analysis is like, oh, I see that word happy in that sentence, you know. But if you do a bigram analysis looking at negation words, you can understand which words are contributing the most in the wrong direction and how much. And so you can get at these issues of how big of a problem these might be for your sentiment analysis. Something else you can start to understand when you look at bigram analysis would be something like this. What if we look at all the bigrams in a text that start with he or she, and then we look at differences in what comes in the second word in the bigram? This is an example looking at, back again at the works of Jane Austen, and looking at what words are more likely to be used after she, and what words are more likely to be used after he. So in Jane Austen's novels, women are more likely to remember, read, and feel, and men are more likely to stop, take, and reply. So we're able to see how Jane Austen portrays gender in her novels there. I also worked on, let's see, will it go? Oops. I also worked on a project with the data visualization people at the Pudding, taking a similar approach, but to an extremely large corpus of film scripts. So we took the film scripts and we removed out the dialogue so that all we had left were the set directions. So the part of the script that tells the actors what to do. The part that's not dialogue, but the part that gives directions to the actors as to what they're supposed to do on screen. And then we use this bigram analysis to see what words are more likely to come after he and what words are more likely to come after she. And we can see that like some of the words at the extremes are words like women were much more likely to giggle, men were much more likely to like gallop and like strap on weapons and do things like that. We actually have metadata on these scripts, so we know like if the writer involved was a woman or a man, so we actually were able to look at differences of that as well. So this was a really interesting analysis to be able to do that I was able to approach using these tidy data principles. So that's available there. You can find it on the Pudding. So I have been up here singing the praises of using tidy data principles for your text mining tasks, right? But it is not necessary or even appropriate for your text data to be in a tidy format for all stages of an analysis. For example, if you need to do some kind of machine learning algorithm on your text data, you probably are going to need to be converting it to something like a document term matrix. The great thing about using this framework of embracing tidy data principles is that you can convert back and forth. And we use the verbs tidying and casting to talk about this. So tidying would be the verb talking about going from untidy to tidy, meaning in a data frame and long and skinny. And casting would be from that tidy format to anything else. So for example, to a document term matrix. And this allows you to have some kind of workflow that, for example, might involve taking your raw, messy text, using tidy data principles to clean the text, to explore the text, visualize and summarize it so that you understand what's going on, do exploratory data analysis, see what are the most important words, what are the most important things that are going on, then could cast to a document term matrix. Once you have a document term matrix, you can perform some machine learning algorithm like, say, topic modeling or a lasso regression or something like that. And then after you complete the machine learning, then you can tidy the output of your statistical modeling procedure, and after you've tidied the output of it, you can use the familiar tools like dplyr and ggplot2 to wrangle and visualize the results of your models. So the tidy text package includes tidiers for most of the common kinds of topic modeling and other kinds of machine learning methods that we use in R for text mining. So this is an example of a recent topic modeling, some recent topic modeling that I did. So I work at Stack Overflow, and we have a lot of text data, which is very fun to work on. So this is topic modeling of Stack Overflow questions. So questions only, just looking at questions. So the topic modeling did not involve any tags. They did only involved the actual text of the question. And so I fit a topic model with 12 topics, and then after the fact, went back to the tags that were assigned to those questions, and then said, what were some of the top tags that were connected to the text of the questions that were assigned to these topics. And so we can see that there are some very meaningful clustering going on here, some very meaningful unsupervised learning that happened here. So topic 1, for example, is the front-end web topic, apparently. It's like CSS, HTML, and so forth. Topic 4 is like the database topic. It's all different flavors of SQL and whatnot. And topic 12 is like a mobile development topic. So we were able to get this, to extract this meaning, this understanding from the unsupervised learning of text here by using this workflow of clean, of tidy, and then cast, machine learning, and then tidy at the end. All right, so this approach is explained in great detail in this O'Reilly book that I've published with my collaborator David Robinson, Text Mining with R. The book is available in its entirety, like the entire content of the book is available at tidytextmining.com. So what we have our goal with this book is to provide practitioners, people who are data analysts and data scientists who are starting to work with text data, to provide a resource for these people who probably have a bit of a background with tidyverse tools and dplyr. It's a first tool to move into being able to handle text data well using these tools. So the first couple chapters are about some of the basics of the tools and how they work. And then the last half of the book is our case studies. So they're complete case studies, like beginning to end, start with raw, messy text. How do you ingest it? How do you clean it? And then how do you get all the way through a case study to get information, like to get insight from it at the end after, say, detailed sentiment analysis or topic modeling or something like that. So that is, so I encourage you all to make use of this resource that we're really excited to have out in the world. And with that, I'll say thank you very much. I'll take just a couple questions, and then if anybody has any, you can find me afterwards as well. Any questions? There's an earlier version of these slides on my speaker deck, which you can find from GitHub. This is updated, but yes. Okay, so can you classify documents in this way? Yes, so I've actually done this. So the way that I have had, so there's various ways you can classify documents. The way that I have had the most success and that I like the best is to use lasso regression. So so then actually you don't even have to untidy often. You don't even have to get like out of the document back to a document term matrix. You can use things still in their tidy form, and then use lasso regression. So in R, it's like GLMNet. Use GLMNet with lasso, and you can then what you're actually predicting on is the words. And since it's lasso, you have so many words, right? You have documents full of words. But with lasso, you are you're finding which words are actually important. So you find and you find which words are not important that you don't need to use to distinguish between, say, two groups. So that's what I have personally had the most success with is lasso regression. Yes. No, did somebody else? Oh yeah. Yeah. Yep. Yep. We actually use it at Stack Overflow. We use it on like job descriptions to help classify where would it belong. Yes. Any other questions? Feel free to find me afterwards. Thank you all so much for coming. I'll see you around. Thank you.